Welcome to the video. Today we are going to solve some of nodes on the longest path from root to leaf node. Okay, as longer as the name suggests, it is very easier question. Okay, so in this question you are given a tree of n nodes. Okay, tree with n number of nodes, and there will be a maximum length path. Okay, and you have to return sum of all the nodes which are there in that path which is having the maximum length. Okay, when I'm saying path with maximum length, this should ring a bell in your head that we are somehow talking about the height of binary tree, the depth of binary tree. Cool. So see in example one, out of the given binary tree with a number of nodes, the path with 4, 2, 1, and 6. 4, 2, 1, and 6 is the longest path. It is very easier. Okay, it is very easier to get with the naked eye. Okay, since every other path stops here, but this path continuing till here also. Hence, this is the longest path. And what are the nodes present in this path? It is 4, then 2, then 1, and then 6. Summing it up will leave you 13. 4, 2, 6, 1, 7, 6, 13. And that is our answer. That is our answer, guys. Coming to example 2, here all the nodes have same path. In that case, there will be multiple answers and you will have to return the path with maximum sum since the depth or height is same throughout for all the leaf nodes. Cool. In that case, you will find the sum. Okay, 1 plus 2 plus 4, 7. 1 plus 2 plus 5, 8. 1 plus 3 plus 6, 10. And 1 plus 3 plus 7, 11. Okay, this is the longest path. 11 is the longest path, and that will be our answer. Okay, so first you will find the height maximum. If height is all the same for all the leaf nodes, in that case, you will what you will have to return the path with the maximum sum. Okay, we will find the maximum sum. So we will use DFS in this in order to find the depth or height. Okay, so first DFS, and let's rename it to rot, from the root to rot. Okay, if not this root, if this is empty, which means either we do not have any root or we are at the leaf node. We are at the leaf node. Usually it signifies that we are at the leaf node, and since leaf node will not have any height, and we are returning both the values, sum and height together, sum and height together. Okay, now there are two variables, max height and max sum. Since this function is returning two values, height and sum both, so maximum out of what? Maximum, if there exists a root, then it should have, it may have left child and right child. In that case, we will find the maximum height and maximum sum of that particular child, left child and right child, either of them. Okay, so DFS the left side and DFS on the right child. Okay, right subtree, left subtree. Cool. We will get max height and max sum, and out of it we will return the site variation, because max height will give you height except the current node. So in that case, you have to return the max height plus one, including the current node, and some maximum which you will get except will get the maximum except the current node, and in order to include the current node, you will do dot plus data. This is it. This is just we have to do just two line. Okay, recursively calling the function, going depth, finding height, finding the sum, then height adding one to the height to get the current height, including current node, and get the and adding root to data to the maximum in order to get the sum along with the current data. Nothing else, nothing more. You will just return it in the main function. EFS, you will pass root, but there's a catch. You will have to return only sum of the nodes and not height. And we are getting both height and sum together. But we have to return only sum. That is why I will return the first value, not both. Okay. And let's submit it and check the efficacy of our solution. Yeah, It did the job in pretty less time. Okay. So I hope you learned a new concept and enjoyed it. Thank you. Have a very nice day.